Hi again. In this example, we have um, an RC circuit, but it is a 90 microfarad capacitor is charged to 10 volt. The capacitor is then disconnected from the battery and connected to a resistor with a value of 40 kilo ohm through a switch. Find the amount of time required for the charge on the capacitor to decay to 60% of its maximum value. There are so many things in this example. Identifying the situation is to be a discharging procedure. The capacitor is already charged. The capacitor is being disconnected from the battery and is just connected with a resistor, and also telling me the time for the capacitor to charge decay to 60%. There are so many things telling me here. It is a discharging process. So to do this, or to calculate this, we simply will say, all right, it's the charge as a function of time, Q max exponential T over RC. Now we don't have the value of RC, or the first time constant, which is easy to be calculated. So tau or RC equal, the resistance is 40 10 to the power 3 multiplied by the capacitance, which is 90 10 to the power minus 6. That all will give us 3.6 seconds. So we know how much is the first time constant. Okay, now he's telling me in the question, or the question telling me, when is the time where that charge, or the amount of the charge stored in the capacitor, is only we have only 60% from its maximum. So we already lost 40%, only 60% left from the maximum. So we can say, all right, here it is. That's 0.6 of the Q max equal Q max exponential minus this time over RC. Okay, now Q max or the Q max, they will cancel each other. I will have ln 0.6 equal ln exponential minus T RC. That simply will give me, I'll just rearrange the whole thing, and it is RC with the negative and ln 0.6. If we just do the calculation here, 3.6 times, that will give me 1.8 seconds. That's the time needed or required for the charge on the capacitor to decay to 60% of its maximum value in this discharging procedure of the capacitor. All right, so this one example. Another example we could also solve in this video, where I have a 10 volt source is connected to a series of RC circuit, where R is 210 to the power 6 ohm, and the capacitor has 3 microfarad capacitance. Find the amount of time required for the current in the circuit to decay to 5% of its original value. Okay, here we go again. So it is a charging procedure here, because I do have a battery with a resistor and a capacitor. They are all connected in series. Okay, I have the value of the resistance, the capacitance, also the voltage of the battery. But as we know from our previous videos where we discussed the situation of the current through the discharging procedure, it is always start the maximum and it will just decay until it's just vanished completely. here he's telling me the question, when is the time I will have only 5% of the maximum. So it's somewhere here. That's almost like it's vanishing. I'm trying to find this time here. Okay, to do this, I will use the formula of the time through the resistor. Okay, I max exponential t over tau. All right, let's find the first time constant to help us. It is 2 × 10⁶ multiplied by 3 × 10⁻⁶. That's quite handy. The answer here will be 6 seconds. Once again, the current through resistor as a function of time all right, here we go again. He's asking for when is this time where I will have only 5% of the original. So here I only have 0.05 from the maximum, or it's the original value. It's already starting the initial value, it's the maximum value. I max exponential minus t over tau. Once again, these values will cancel each other. I'll take the len for both sides just to save the time with the calculation. That will give me minus time constant len 0.05. Okay, so it is minus 6 times len. It's giving me kind of like it's almost -3. Okay, so the answer will be 18. Sorry, take this off and fix it. It's 18 seconds. So after 18 seconds from turning the switch on in the circuit, the current will be only have 5% of its maximum or its original value. We can also calculate the maximum current. We know that it is by voltage. It was 10 over the resistance, which is 2 × 10⁶. So okay, so the original value was 5 microampere. So after 18 seconds, I will have only 5% of this 5 microampere. All right? I hope you found this video useful with these two examples and practicing the equations and the concept of the percentage decaying or rising or whatever, or how much left, and finding the time for a certain procedure or concept. Thank you very much.